Alright, so I'm just gonna show you Taylor series. I redid this problem. I wrote everything else, so I'll explain it. I'll send you a picture of everything after. So pretty much the formula says, I'll start with the question. It says find the first four terms of the Taylor series for the following function, which is this. They give us this function, and they said they give us a equals 1. So pretty much the formula says we have to evaluate f of a, which is just a function at a, f prime of a over n factorial. So this is the first derivative. Then the second derivative we value at a also n factorial, which is 2, and so on and so on. So this, in this case, they want us to find four terms. They could ask for 6, 10, whatever. So we have the function ln of x. In your case, you had like 1 over x, but it still applies. Same thing. So we take the first derivative, f prime of x, which is just 1 over x. Second derivative, f prime of x is negative x squared. Third derivative, which is just 2x cubed. And fourth derivative, which is negative 6 over x to the fourth. Right? So now we have to evaluate everything at a, which is a equals 1 to give us that. It could give us 2 or whatever. So if we evaluate the function at if we evaluate the original function ln of 1 right here, this is our a right here, right? So we evaluate everything at a, so ln of 1, which is a 0. This wouldn't count as a term, so when we look for Taylor series, we have to look for non-zero terms. So that's why I have 1, 2, 3, 4, 5 instead of just, like, if I would have just had that, but that wouldn't count. That would just be 3 terms because we don't count the 0 as a term. So that's why I continued to the fourth derivative. You could have just done like 6, 7 derivatives, and then like you can just evaluate them, and then you just need 4 terms. So in this case, we evaluate the original function, and we get 0, so we don't count that. So we take we evaluate the first, second, third, and fourth derivative at 1, and we get 1, -1, 2, and -6, right? So now all we just have to do is pretty much just plug into this formula, and this formula can continue until like however many terms we want you to find. So if we just plug in, so f of a is 0, right? And we just plug in f prime of a, which is 1. We found 1 up there, and this is the first derivative, so 1 factorial times x minus 1. X minus a was given, so just x minus 1. Same thing for the second derivative, f prime of a, so we got -1 over the 2 factorial, which is like the second term, I guess you could say, and then it's just multiplied by x minus a squared, x minus 1 squared. Same thing with the third term. You can continue this on, but we just need 4 terms. So we got 2 for third derivative, so 2 over 3 factorial, x minus 1. Same thing, -6 over 4 factorial, x minus 1 to the fourth. We just follow the formula. This is a pattern to however many terms they want. If we simplify this, I simplified it as like just x minus 1. 1 factorial is just 1 times 1. And then I just brought out the negative, so I'm left with x minus 1 squared over, I simplified the factorial to see if I can cancel out with anything on the top. No, I can't. So I'm left with 2 times 1. Now, I did the same thing here. I just try to simplify. So 2 times x minus 1 cubed, and I could cross out with something at the bottom because 3 factorial is 3 times 2 times 1. So I just crossed out the 2 and I'm left with 3 on the bottom. Same thing here. I bring out the negative, and then I see if I can cross out with anything on the bottom. So I'm just left with 4. Now, you see I didn't 0. So this 0 does not count as a term. It's a constant, yes, but it does not count as a term. So these are pretty much our 4 terms that they want us to find. So that's why I said like 0 wouldn't be counted as a term. Like when you evaluate the function and you see 0, or even if you evaluate like one of the derivatives and you get 0, then you have to like continue to add one more to replace that 0 that you found. So in this case, the first term that we found was 0. That doesn't count. So everything else after, we have to like find 4 four terms. So this first, second, third, fourth. So for example, if we found like the third derivative and it equal to 0, we'd have to go on to the fifth derivative. So we just have to continue on until whatever the axis. I'll send you a picture so you can see what I did.